I am James Rinian C. Salenga, and over the past 2 semesters, we have worked on hands-on activities using real components.
I am Diana Katrina Marasigan. Our class focus on learning the uses and how the different components are used in Arduino project and how they work.
And I am Alvin Petersus, and we're going to discuss the journey that we faced in this kind of activity.
Hi, I am Dave Harvias Beneto, and this video not just reflects what we feel, but how our understanding developed over time.
I'm Jacob L. Marquez, and we'll share the challenges we faced and how debugging helped us learn.
And I'm lovely Princess Esther Level. This reflection is for future students who want to know what to expect, how to succeed in this robotics class.
The purpose of the servo motor is to create precise and controlled movement. Unlike a regular motor that spins freely, a servo moves to a specific angle which is useful for accurate positioning. It works by receiving a signal from the controller telling it which angle to move to. Inside there are gears and sensors that are constantly checks the position. It's helpful in projects like robot arms, automatic gates, and sorting systems, where controlled motions matter more than speed. Compared to a DC motor, a servo motor is slower but more accurate. Compared to a stepper motor, it's easier to control but has a limited range of motion. Our problem includes the servo motor jittering and not rotating at all.
The ultrasonic sensor allows the system to measure distance and react to its environment. It works by sending a sound wave and measuring how long it takes to bounce back. The longer the time, the farther the object is. The sensor is useful in obstacle-avoiding robots, parking systems, and automatic doors. Compared to infrared sensors, ultrasonic sensors are more reliable in different lighting, but they can struggle with soft or angled surfaces. While working with the ultrasonic sensor activities, we face many challenges, such as working with loose wires, causing the projects not to work immediately, and to solve this, we asked for wires to other kits. We also had troubles with the coding as we didn't have our coder for that day. We made numerous mistakes in entering the codes for each project, delaying the project even further in
The I2C LCD provides visual feedback, letting users see what the system is doing. It works using the I2C communication method, which sends data using only 2 wires, making setup easier and less confusing. The LCD is useful in projects like distance monitors, counters, or alert systems. And it can display messages, warnings, or system status. Compared to a regular LCD, it uses fewer wires and it's easier for beginners. The challenges that we encountered in the LCD is having an error where we upload the code. It sometimes only displays glitch letters, which we solved by changing the wires and double-checking the code. Also, some LCDs had loose bolts, so we had to adjust it with a screwdriver.
System thinking and integration. We learned that components are more powerful when integrated into a system. Besides the main components, we also use LEDs and buzzer for feedback. The ultrasonic sensor measures distance, the servo motor response, and the LCD displays the reading or messages. The LED, LCD, and buzzer gave real-time feedback. LEDs gave quick visual signals, buzzer provide audio alerts, and the LCD showed exact numbers or status. Integrating the LCD with ultrasonic sensor helped us see distance in real time, which made debugging and understand the accuracy easier. Additionally, TAS showed us that LCD can display messages, warnings, and system state, demonstrating its potential. This integration helped us understand that automation is about input processing and output working together, not just an individual part.
debugging experience. We face technical problems like servo motors jittering, ultrasonic sensor giving wrong distances, or LCDs not displaying anything. When the servo motors only vibrate but not ringing, it means that the servo motors is broken. We also experienced the failure of using the ultrasonic sensor because it detects the wrong or a different object while using.
Across 2 semesters, our journey in robotics involved both success and failure. In terms of technical challenges, robotics was not always easy, especially in coding and wiring, as we encountered issues such as servo motors that jittered instead of moving properly, an ultrasonic sensor that malfunctions due to loose or incorrect connections, accidentally wiring VCC instead of GND, and an LCD in displaying unusual characters instead of clear text. Regarding teamwork and task management, handling wiring, coding, and documentations simultaneously was challenging, but dividing responsibilities made our workflow smoother and more efficient.
Our key takeaway is that system works best when each part communicates clearly.
We conclude that memorizing doesn't help for understanding, but testing.
Robotics show us how ideas become real systems.
These skills gave us the knowledge to be ready for our future challenges.
By understanding the system, the problem was solved.
This class inspired us to explore technology further.
So future students, stay curious. What we felt here is lost to the end.